All right, now this is multiply out or FOIL the following two problems. We're actually going to factor some more today, but it's really nice to see how things work and compare these two examples before we try to go backwards. So, all right, when we're FOILing these out, notice some of the similarities and differences as we do them. So FOIL is just multiply this times this. This is not new to us to FOIL. So x squared plus the 9x, we're multiplying here. Multiply these two together is minus 9x. Multiply these two together, you get minus 81. All right, now we'll go ahead and combine like terms in the middle here. And what's nice about this is really what happens is this is a 0x. Now, generally we don't write the 0x. Here I'm going to write it just to compare something later. And really the answer to this, though, is x squared minus 81. And so you could, if you were foiling that, you could skip this step right here and go right to that. All right. Now this next one, okay, we'll FOIL this. X times x is x squared. X times 9 is 9x. But here I have another plus 9x. So there's a difference right away I just noticed. And then here's another difference. 9 times 9 is positive 81. So here these will not cancel. And that's really the big thing we want to note here. And I'll get back to that in a second. So we're going to combine like terms here. This is going to be an x squared. 9x plus 9x is 18x. And then here we have a plus 81. And FOILed out, this is complete. Now I'm not going to write a bunch of stuff for what is the difference. I'm just going to talk about it and do a little highlighting here. So the big difference here is really this 0x as opposed to the 18x. When we multiply something that looks like this, and here's where the difference comes from, is I have a minus here and a plus here, which allows these two middle guys to be opposite signs. Whereas here, a plus and a plus keeps the two middle guys with the same sign. So that's why there's a middle term here and not here. So when we're factoring, there's two different things, and number 1 and 2 down here are going to explain it very well. So that's really the difference. So we don't have to really write a bunch of stuff here. We're really just thinking about it. But I will write this. This has a name to it. It's a special type of factoring. It's called difference. And I'll just abbreviate that real quick. Difference between two squares. This over here I'm not going to write. It's actually called a perfect square trinomial because it ends up factoring backwards. If we were to factor this way, you would get x plus 9, x plus 9. And as most of us know, we would generally write that as x plus 9 squared, right? But we just wanted to start out there. All right, so in this problem down here, it says factor the following completely. What we always do before we factor is GCF, GCF, GCF. Always try to get a GCF out of both terms, and in this case, there aren't. All right, the other thing I do want to notice right away is this looks very similar to this right here, the x squared minus 81 result. So when I factor, I'm actually going this way, right? All right, and so I want this to look something like that, and it will become very similar. Now, two terms, okay, again, GCF, and then I want to see, is this the difference between two squares? Now, going back to this again, x squared is a perfect square because x times x gives me x squared. And 81 is a perfect square because 9 times 9 gives me 81, or if I take the square to 81, I get 9, which is not a decimal. So this x squared is a perfect square. 25 is a perfect square. And I have a minus. So this looks to me like the difference between two squares. And so I'm going to factor it very similar to what like I FOILed the other ones, but I'm going backwards. So now, there is an approach we've used for factoring before. So I'm going to actually show you that this can be done like this, where I can actually put the 0x in the middle like I had here, and then try to factor this by guess and check like you've done before. So I know with a 1x in front, an x times x will be the way I get x squared. So we're going backwards, so we just got to think backwards. Now with this number right here, numbers that multiply to 25, and in this case, sorry, negative 25, but add to 0, well, 1 and 25 will multiply to 25, and 5 and 5 will multiply to 25. However, if I try to add 1 and 25, we have to think of their signs also. To get a negative, one has to be plus and one has to be minus. So if I try to add these two together, there's no way I'm going to get a 0, right? But if I try to add 5 and 5 together, if one's positive and the other one's negative, then I do get 0. And so notice what happens here. This is plus 5, and this is minus 5. Numbers right here that multiply to the negative 25, and add to the 0, give me that answer. And this is complete. Now, notice the similarity between what happened here. If I was to go backwards here, look, the square root of 89 is 9, and then this is 9, so minus and plus. Because 9 plus negative 9 is the 0, and negative 9 times 9 is 81. So that's really kind of a short factoring problem if we don't go through and write 0x. All right. Now, one last thing on this problem is you always know if you factored wrong or right because you can always check real quick. X times x is x squared minus 5x plus 5x. The 5x in the middle will cancel like up here. And then 5 times negative 5 is negative 25. So it checks out. All right, in number 2, the first thing I notice right away, oh boy, I've got a plus 25. This problem often fools students, and what happens is it's not really the difference between two squares. So I can try to factor it like it is. I could go ahead and write, the 0x and the plus 25. A lot of times we'll stop writing this when we get used to these. And go ahead and try to factor this like this. I want to find two numbers that multiply to 25. And add to 0. But notice this is positive 25. And so I could try x plus 5 and x plus 5. Now this is going to actually look very similar to this up here. Because x squared plus 5x plus 5x. But what happens with those two? In the middle here, in the middle term, I would have a 10x. Which there's no middle term here, so this can't possibly work. Well, alright. What if I tried minus 5 and minus 5? Because those do multiply to add to 25. But what happens in the middle? Oops. That's really bad. Sorry about that. Just noticed I should put the x there. So if I try minus 5 and minus 5, I get x squared minus 5x minus 5x. Now I get a negative 10x in the middle. So there's no way to factor the sum of two squares. All right? So what we generally do here is I'll erase my work, or you could cross it off and write not factorable. It seems like this should factor into something like this, but it doesn't because of the plus. All right, next problem. All right. So I've got number 3. I've got 2x squared minus 200. Now again, two terms. I've got a minus in here, so I'm thinking maybe difference between two squares, but hey, look, I got a GCF here. So I'm going to factor out the 2, and I get an x squared minus 100. Whenever you're factoring out a GCF, you're really just dividing whenever you're factoring anything. So I like to kind of think of it backwards. 2 times x squared would give me 2x squared, and 2 times negative 100 is negative 200. So I have this part done correctly, but guess what this is? Two terms, perfect square, difference, perfect square. And so I'm not going to write the 0x in the middle this time. I'm just going to go right to factoring it, because usually students, you get the hang of this. So x squared minus 100, since 100 is a perfect square, I'm really looking for numbers that multiply to negative 100 but add to 0. And the only way that's going to work if one of them is plus 10, which is the square root of 100, and if the other one is minus 10. All right? Because in this case, the middle will cancel because they're opposite signs. All right? And that's factored completely. All right, so we'll box it up. All right. Now, a common mistake on a problem like this is you factor out the GCF as a 2, and then you accidentally leave it off here. And so you got to make sure that 2 follows through. All right? So now, the next one, number 4. Again, two terms. Uh-oh, I've got a plus here. But I've got this sneaky little negative in front. So I can still factor out a GCF. Now, let's see what happens. Negative 1. Now, keep in mind, sometimes you factor out a GCF and the rest won't factor and you're done. But this one, let's see. If I factor out a negative here, this becomes positive 1. And this positive becomes a negative 81. Ah, sweet. Now I have the difference between two squares here. Now we don't really need the 1. We can just write a negative. And we're going to factor this like we did the 1 over here. 81 is a perfect square. X squared is a perfect square. What's the square root of 81? 9. Or I'm looking for numbers that multiply to negative 81 and have a 0x in the middle. So multiply negative 81, add to 0. They have to be plus and minus 9. Plus 9, x minus 9. Now keep in mind, I could write x minus 9 over here and x plus 9 over here. That's still just as good. All right. Now again, you can always check this. Every factoring problem you do, you should know if you're right before you move on because you can foil it back in your head. All right, number 5. All right, this is looking a little different. Now, why? Because now I have three terms. So this is actually going back to some old factoring to review. And so with three terms, can I factor out a GCF? No. There's a 1 in front, which is generally the easier type of trinomial factors. So I'm going to go right to guess and check. Now when we guess and check, we know that 1x times 1x has to give me the x squared. And we're looking here for now numbers that multiply to 4, this 4, but add to the middle 4, right? A little confusing because they're both 4s. So I can write like a 1 and a 4 out here just to keep track, because 1 times 4 is 4, and 2 times 2 is also 4. So which one of these two also add up to 4? Well, 1 and 4 doesn't. That adds up to 5, so those don't work. 2 and 2, oh, wonderful. So they both work. Now the other thing is both these are positive, so I didn't really worry about what's positive or negative here. So plus 2 and plus 2. All right? Now fold it back. X squared plus 2x is plus 4x, and then plus 4. It works. Now a lot of times we'll write ones that look like this as the quantity squared. All right? All right, now I want you guys to try number 6. So you have to come to class with it done. And number 7. All right, so number 8. Here I have two terms and a subtract, so I'm going to look for the difference between two squares, but I have to factor out a GCF. In this case, it's an x. A little tricky on this one. When I divide x cubed by x, I get the x squared. When I divide negative x by x, it's minus 1. And then what happens here is nicely I have another difference between two squares in there. So I get x times. Now, this is x squared, so this x and this x will multiply to x squared, numbers that multiply to negative 1, but add to the 0x that would be in the middle there. Or the square root of 1 is plus 1 and minus 1. And this is factored. Again, don't lose that x right there, that's the GCF. All right, we saved a really tricky one for last. This one's similar to number 5. It's a trinomial, but notice in number 5 we had a 1x squared, and here we have a 12. So that makes this really a lot more complicated. So when we guess and check, we have to take into account that 12. And so what's going to happen is we're going to find numbers here for spot 1 and 1 here that multiply to 12x squared. And so 1 and 12 will multiply to 12, 2 and 6, and 3 and 4. And so then this 6 has to occupy these outside spots. So numbers that multiply to 6 are 1 and 6, and 2 and 3. And the other thing that's complicated about this is you're going to have to multiply these two together and get some number, and you multiply these two together to get some number, and those have to add up to 17. So it's a lot more complicated than just a 1x squared. So I literally would just start here with 1x and 12x and guess and check. And you definitely should use pencil when you do this because you're going to have to erase. So then, now, everything here is a plus. So I'm going to go plus here and plus here. And so I'm just going to, with this pair right here, I'm going to put the 1 here and the 6 here and see if it works. Well, 1 times 12 is 12x. And this 1 times this 6 is 6x. 12 plus 6 is 18, not 17. So I know this doesn't work. But what if 6 could go here and 1 goes here? Well, we can see right away that's not going to work. Because 6 times 12 is this becomes 72. And then this 1 times this is 1. But 72 plus 1 is way too big. All right? So I know this is not going to work. So what does that mean? That means my 1 and 6 never could work. So now I'm going to try the 2 and the 3. So I'm going to put the 2 here and then the 3 here. Now you can kind of see where this is leading. All right? If the 2 and the 3 work here, then I'm done. If not, then I got to switch the 3 and the 2. And then if that doesn't work, then I cross off 1 and 12 and start that whole process off again with 2 and 6. All right? And so I'm going to stop here. This doesn't work. We can do this real quick. 2 times 12 is 24x. And we already know that we need 17 here, so this is way too big. So some of your guess and check you can kind of avoid by just thinking about these numbers. So what I want you to do is finish this for class, and I'll tell you right now that the 1 and 12 won't work at all. So I'll give you at least up to there. All right, so now what you would do is kind of start this over and put maybe 2x here and 6x here, and then start with these values over again. And then 1 and 6 has to be back in the mix, so you have to kind of start over. All right, okay, finish that for class tomorrow, and we'll see you in class.